Okay. So what we're saying is that something squared plus something squared is equal to something squared. And what we're saying is that what goes in here is the A, the B, and the C. So we'll put a 3 over here, a 4 over here. Oh, I'm sorry. The 4 over here, the 3 over here, and the 5 over here. So we get 16 plus 9 is equal to 25. Oh, sorry. I put the X over here. Sorry about that. So now we get 25 is equal to x squared. And to get rid of the x squared, I'm going to square root both sides. Now, normally when you square root both sides, you add a plus or a minus. But in this case, we're not going to add a minus because we're asking ourselves, how long is this side? So for example, if this is 3 inches and this is 4 inches, how long is this side? Well, we don't say it's negative 5 inches, it's a positive 5 inches. So whenever we talk about length, we're always talking about positive length. This is a positive 5 inches. So we get x is equal to 5 like that. Just give everyone a chance to copy. So let me give you one to try. So let's say we give you something like this. Let's make this 10. Let's make this 3. So go ahead and give that a shot. Right? Remember that the legs are the A and the B. And the hypotenuse is the C. And you don't have to care which one the A and B are. You just have to get the hypotenuse right. So let's call this A. Let's call this B. But if you call this one A and this one B, that's okay. The most important thing is that you get this one to be C. So now you have something squared plus something squared is equal to something squared. And then you have your A, B, and C. So go ahead and fill that out. Now, when you get down to the square root, you won't be able to square root this number. Oh, I'm sorry. I should have this, and then I should have this and this. You won't be able to square root this number, and that's okay. Just leave it in radical form. With the calculator you have, you won't be able to calculate it, so just leave your answer as a radical. So I have a 3, I have a 10, and an X. So then that turns into 9 plus 100 is equal to X squared. So X squared is equal to 109. And then let's square root both sides. And we get X is equal to 109 square root. Okay, now the other way they can give you this problem is that in the prior two problems, we were missing the hypotenuse. They can also give you this problem where you're missing a leg. So in this case, I'm going to give you a hypotenuse value. So let me call it, I don't know, 13. And we'll call this one, I guess I'll put it in blue. That's what I can do. 13, and we'll make this one 12, and we'll make this X. And go ahead and find X. So this one is A, this is B, this is C. Now, the big mistake everyone makes on this problem is they automatically put the X on the other side of the equal sign. But we're using this formula here, so we have to use this order of A, B, and C. So we're still doing something squared plus something squared plus is equal to something squared. And this is still an A, B, and a C. So the X is going to go here, not over here. So that's the part that you've got to be careful about. So we have X, 12, and 13. So go ahead and figure this out. So I have X squared plus 144 is equal to 169. And then we're going to subtract 144. And we get X squared is equal to 25. And then let's square root both sides. And then X is equal to 5. So let's do one more like this, where we're missing the hypotenuse. I'm going to draw the rectangle a little different this time. Sorry, the square. No, the triangle. Sorry, a little different this time. Let's do that one. So the hypotenuse is a side that doesn't connect to the right angle. is your A, B, and C. So you get 5x and then 7. So we have 25 plus x squared is equal to 49. And then we'll subtract 25 from both of these. And we'll get x squared is equal to 24. And then we'll square root both sides. Let me give everyone a chance to copy, then I want to say, show you a little cheat. Okay. So let's look at the different types of answers we're going to get. Excuse me, I got a small little head cold, so I'm going to be sneezing all day. If we look at the types of answers, we get radicals or we get whole numbers. Those are the two types of questions we have. Now, when they use a Pythagorean theorem in the middle of a larger problem, they'll most likely want to have a whole number as an answer. Now, there are only three triangles that they can give you on this test using the kind of calculator that they're giving you, where you'll get a whole number. Okay, so oftentimes you can cheat the process and not actually use the Pythagorean theorem and just use for these number combinations. So this first one is 3, 4, 5. Okay. And then the next one is multiply each one of those numbers by 2. 6, 8, 10. Okay, so those are right triangles. So 3, 4, 5, it's not hard to memorize. Then multiply by 2, 6, 8, 10, not hard to memorize. And then the only one that's really hard to memorize is 5, 12, 13. Okay. So if you see any of these combinations, so over here, 13, 12, 13, 12, I can automatically say 5 without doing all of this work. Now, let me show you how this can come up on your exam. So we had done like composite shapes before, meaning that in the past we had done shapes that look like this. But now let's do shapes that look like that have triangles in them also. So let's say I give you something that looks like this. Okay. And we'll make this one we'll make this one 10. We'll make this one 5, and we'll make this one 13. Now, they can ask you to either find the perimeter or they can ask you to find the area. So I'm going to give everyone a chance to sort of digest that. Look at it. Go ahead and try it. Think about it. Now, for both of these questions, we would have to know what this value is over here. That's the big question. Okay. Now, if I knew what this was, I could just add these all up, and I would have the perimeter. And if I knew what this was, I could split this up into two pieces. And I could find the area of the rectangle and add it to the area of the triangle. And let's remember our formulas. This one is width times length. Right? This side times that side. And this one is 1/2 base times height. So 1/2 this times that. Okay. So let's first cut this right here. If I can find out how long this is, I can know how long this is because this length and this length are exactly the same. So I know that this part is 5, right? Because this length and that length are the same. So that means that this length is 8. So now I have this triangle right here that looks like 10, 8. And when I look at my chart to do the Pythagorean theorem, I can see that it's 6. Right? Do you see how quick that was? Where you can go like, oh, triangle, 10, 8, 6. Right? 3, 4, 5 times 2. So what I usually do when I have these problems is before I start the problems, I kind of know that, you know, especially if I don't see any square roots in the answer, that it's going to be one of these triangles. This is the only triangles they can use. I'll just write this down and go like, okay, which one matches? Now, if you didn't see that, you could use the Pythagorean theorem. And say, this is A, this is B, and this is C, and go something squared plus something squared is equal to something squared. So you get, we know what 10 is. We knew what 8 was. This is what we didn't know. Okay. So all I was trying to show you is that you could skip the time to do all of this, the Pythagorean theorem, if you memorize this 10, 8, 6. Okay. I ran through that pretty fast, so go ahead and copy it down, and then if you have questions, just ask me. Okay. So we know that this length is 6. So that means this length is 6, because the length of this side and that side are the same. So when we try to find the perimeter, we get 6 plus 5 plus 10 plus 13 is equal to 21 plus 13 is equal to 34. Okay. Give everyone a chance to copy. Now, when we do the find the area, what happens is that we are getting rid of, let me get rid of some of these that make this more confusing. Right? We just care about length times width, right? So this rectangle is 5 and 6. Okay. And then this triangle is 6 and 8. So we have 5 times 6 plus 1/2, 6 times 8. So that's equal to 30 plus 3 times 8, 30 plus 24 is equal to 54 like that. Let me give everyone a second to copy. Does anyone need extra time to copy? Okay, let me just yell if you do. All right. Let me erase this part then. Okay. So this is one that I've seen on an old practice exam for TEAS. So this is definitely fair game, and it looks something like this. Looks like that. Then you have something like this. And it goes 5, 5, 8, and then this is we'll make this 10 and 10. Yeah. Okay. Now, what we want to do is find the same thing. We want to find the perimeter, and we also want to find the area. Okay, so this is basically a big triangle on top of a on top of a rectangle. Okay, so let me give you a few minutes to try it. And then see if you can see the right triangle. Right? That 5, 5 is not a right triangle. Okay. This is not a right angle. Okay. Now, this is a very common trick. See, this 5, 5, they want you to see that this is an isosceles triangle, meaning that the left and the right side are symmetric. So if I have a triangle that looks like that, that's symmetric, if I draw something straight down like this, I have two symmetric triangles. Okay. And since this is 8, that would mean that this is 4 and that this is 4. Oh, I guess this is dumb. Forget about the perimeter. We can already compute the perimeter. So just find the area. Okay. So what you need to do is you need to find the area of this guy. And it'll be the same as the area of this guy. And then to find this area is pretty straightforward. We gave you all the information previously to find the area of the big square. Okay, but for this one, you need to do 1/2 base times height. So the question is, figure out what this is. Look over here at your right angles, at your right triangles. Okay. So this is what I see over here. 5, 4, 3. So this should be 3. So we know that the area of this one is going to be 80, 10 times 8. So the area of one of these triangles is equal to 1/2, and then this is 3, and that's 4. 4 times 3 is equal to 2 times 3 is equal to 6. So the area of this one is, let me make this in green so it's not as confusing, and 6. So that's 6 also, because they're symmetric. So we have area is equal to 6 plus 6 plus 80 is equal to 96. Let me give everyone a chance to copy. Okay, so the next thing we want to work on is mean, median, and mode. Median, mode. I guess we'll add range too. Actually, let's just do mean, median, mode. I haven't seen range, so. Okay. Now, what mean is the same thing as average. So what you want to do is add all the numbers. And divide by how many numbers? So let's say I give you find the mean of 1, 3, 4, 12. Okay. So add the numbers and then divide by how many you know. So the mean is equal to 1 plus 3 plus 4 plus 12 over 4 is equal to 20 over 4 is equal to 5. So that one people are pretty good with. Okay. Let's look at median. What is the middle number? Okay, so go ahead, pick that. Maybe we will do range also. Just be careful. So when we go, what is the middle number? So let's say I have 5, 1, 2, 8, 6. When we say middle number, we first have to order the numbers. So we have 1, 2, 5, 6, and then 8. And you say, what's the middle number? Boom, right here. But the problem is, what happens when I have an even number of numbers? Okay, so that's what we're going to do next. Right? So let me give everyone a chance to copy. Okay, so let me go find the median. And then we have, let's go 5, 1, 8, 6, 2, 7. Okay, so first order the numbers. So go ahead and order the numbers. Okay. So we have 8, 7, 6, 5, 1, 2. Okay. Now what you want to do is you want to take the average of the middle two numbers. So you want to go 6 plus 5 divided by 2, right? Just taking the average of the middle two numbers. Oh, wait, what did I just do? It doesn't matter. Let me do that again. I did it backwards. I have the 1 and 2 wrong. 1, 2, 5, 6, 7, 8. Sorry about that. I might be having a stroke. Okay. So you just want to take the average of the middle two numbers. And then this gives you 11 divided by 2, or 5.5. Okay. So go ahead and find the median of this. We'll just put 4 numbers down. But we'll make them big so it's not obvious. All right. So these 4 numbers. So you have 9, 21, 64, 82. And then you take them and you go, what is 64 plus 21 divided by 2? We're going to go 74.5. Okay. Okay. So let's make sure we write these on the side, and we'll do all of them one more time. So the mean is equal to the average. The median is equal to the middle. The mode is what number appears most often. Numbers. Okay. So mode. And these should all be quick kills on your exam. When you see it, you should be happy. You should knock it out really fast. Okay. So when we say find the mode of 2, 3, 4, 3, 7. Let me let you catch up to me. The mode is equal to 3, right? And that's pretty obvious. 3 comes up the most often. Now there's a couple ways for me to trick you using mode. Here's one. So go ahead, copy that. So if you go, what number comes up the most often? Notice that I said number or numbers. Mode can be more than one number. So the one trick is that you can have more than one number as a mode. Now, the last trick is what happens when all of the numbers are the same number. Let me give you a chance to copy. Now, it depends on the book. Some books will say no mode. Other books will say 2, 3, 4. Now, this is an issue if this is a fill-in test, but because you're multiple choice, look for this or look for this, right? I tend to lean on no mode. If you see both of these, I would write no mode. But if you see only one of these, pick one. But if you see both, do no mode. Okay. Now, what the range is the largest number minus the smallest number. Okay. So if I was to ask you, find the range of 5, 8, 9, 1, 13, 26. You'd have 26 minus 1. Photo of this. Okay. Now, just to review everything, I'm going to give you one set of numbers, and we're going to compute the mean, median, mode, range of all of these. Okay. So let's go find mean, median, mode, range of 1, 7, 13, 19, 19, 1. Yeah. So for the average, add them all up, and then divide by how many there are. Six. So this is 20, 20, 20. So go ahead and do the median. So the key thing is make sure that you order everything. 1, 1, 7, 13, 19, 19. And then we're going to take the average of the middle two numbers. If it's even, I mean, if it's odd, we'll just take that one number. But if there are an even number, and you take the average of the middle two. Now, my guess that if they give you this question on the exam, it'll be out of order, something subtle like this, where you're like, oh, I missed that, right? Because the TEAS people are kind of jerks. And they'll probably have an even number of numbers, because that's the hardest way to give you the problem. Now, in terms of mode, we want to know what number comes up the most often. So in this case, the ones come up twice and the 19s come up twice. So its mode is equal to 1 comma 19. And then the range is the biggest number minus the smallest number. Okay. Let's take a 10-minute break. Unless anyone has questions, let's take a 10-minute break and we'll get back to this right after that. Okay. So after this, we'll work on rate of change. I have a big old worksheet for you. Okay, let's get back to it. Let's work on rate of change. Now, let's talk about rate of change. Clear all of this. Now, when we talk about rate of change and slope are exactly the same thing. Exactly. Now, the only difference with rate of change and slope is that slope only works off of a straight line, whereas rate of change may work off of a curve. Now, even though it's working off of a curve, you're going to pick 2 points on that curve, and then you're going to say, hey, what's the slope of those 2 points? So let's remember our key points for slope. Okay, so for slope, and then rate of change. Okay, so to figure out the rate of change or slope, and we're just going to say slope for right now, but this is also true of rate of change. Just think of them as the same thing. The key thing is y2 minus y1 over x2 minus x1. So if I asked you a question off of a table, so find the rate of change between 2 seconds and 4 seconds. And then they just gave you some table that said seconds. And then they said, I don't know, the height that you jumped or the height that you were at. And at 1, you were at 5, and at 2, you're at 6, and at 3, you're at 8, and at 4, you're at 10, and at 5, you're at, I don't know, 13. Okay, then we'll give you a chance to copy. Okay. Now, when they give you these values, these are going to be your x values. So because they said 2 and 4 seconds, I know that this is my x, then I know that this is my y. Now, the reason why I'm saying that is because sometimes they'll give you the same chart horizontally, which you may not be used to. 1, 2, 3, 4, 5, 5, 6, 8, 10, 13. And you may be confused, wait, which one's my x and which one's my y? It's the one that they mentioned in the question is the x. Okay. So we're looking at 2 seconds and 4 seconds. So we're looking, so go ahead and plug that into go ahead, plug that into that. Right. Here's my y2, y1, x2, y1, x1. So So this turns into 10 minus 6 over 4 minus 2 is equal to 4 over 2 is equal to 2. Okay. Now, it doesn't matter whether they give you the table vertically or if they give it to you horizontally. Usually, if you're not sure, the x is on the left or the x is on the top. Okay. But you can know by when they give you the question that this is the x. Let me give everyone a chance to copy. Okay. Now, the other way they can give you this question is that they can give it to you with a curve. And that's how a rate of change is different from slope, is that you may get it from a curve. Oops, go down here. So let's go from here. And then let's call this 2, and let's call this, I don't know, 6. Like that. And then let's make this over here 3. And then this over here. Let's make that 7. Let's make that bigger. Let's make that 13. Okay. So what they're asking you for, or what they would ask is, find the rate of change between 2 and 6. Okay. Now, this is the same thing where what we're really doing is we're trying to find the slope in between these 2 points. Okay, so let me give you a chance to copy a little bit. So they won't give you that green line. They're going to give you the red line, and all you're thinking of is what's the slope between those 2 points? So we have this over here, which is 6 comma 13. And we have this over here, which is 2 comma 3. Yeah. And we have rate of change is equal to y2 minus y1 over x2 minus x1, which is equal to 13 over 6 minus 3, 2. And that gives me 10 over 4, which is equal to 5 over 2. Okay. Now, when my slope is increasing, okay, or let me put it this way. Whenever you describe a curve or a line, we're always talking about it going left to right. So if I'm in a car driving this direction, when I'm driving up, when I'm driving onto this line, I'm going up. We call this increasing slope rate of change. Okay, so you're going up, you're increasing, and also your rate of change is positive. So it's going to be a positive value. Okay. So you're increasing, you're going up, and you have a positive value. The value here a little bit more. Okay. Okay, because sometimes they'll ask you to describe the rate of change. Or they'll just ask you the sign of the rate of change. Oh my goodness, what was that? Now, in the same way, I'm a car driving on this road. I'm going down. My rate of change has a negative value. And I have a decreasing rate of change. Okay, now I sent a bunch of worksheets to you yesterday night in your email. And then in the chat, I put in a worksheet. It's called the average rate of change worksheet. Let me show you what it looks like. Does anyone need more time to copy the board? Are you okay, Kareem? Okay. So the average rate of change is just right here. Okay. So we want that worksheet right there. Okay. And then I also put it in the chat. So let me give everyone a minute to find it and look at it. And then once you find it, it will look like this on the top. Let me do a new share. Okay. So let's go down a little bit. And see, all this stuff is basically telling you what I tell you, the y2 minus y1 over x2 minus x1. They just write it in sort of function form, okay? But we can think of this just like as we did in algebra. Okay, so let's get to an actual problem. Okay, so let's look at this one over here. So what this one wants to know is which interval has the greatest rate of change. Now, we talked about before that if I was going this way versus going this way, okay, this has a positive rate of change. Oops, sorry. Let me pick a different color. Bigger. Okay. And we know that this one here would have a negative rate of change. But the problem with this problem is that if we look at the rate of change of each of these intervals, okay, so let's look at 0 to 1. So from 0 to 1, I went up 2. That's too big. Let's make this smaller. Oops. Gosh darn it. Okay. Let's make my arrows a little smaller. Okay. So from 0 to 1, I went up 2. And then from 1 to 2, I went up 3, right? 3 boxes. From 2 to 3, I went up less than 2, like 1.5. And then from 3 to 4, I went up 1.5. So you could see that the distance that is largest is between oh, I'm sorry, I did these wrong. I didn't realize that there are 2 blocks. Okay, I'm going to do that again. Okay. So before we go too far, when I have 2 arrows pointing in the same direction, the one that is pointing more steeply up. So it's this blue one over here. That one has the greater rate of change. Okay. Let me turn down my other computer here. It's pinging at me. Now it has a greater rate of change, not because it's longer, but it's pointing up more. Okay. So what we want to look at over here to see which one has the greater rate of change, at every interval, we want to see which one goes up the most boxes. So when I go from 0 to 1, I went up 1, 2, 3, 4 boxes. Okay. So I am looking at this arrow here. It went up 4 boxes. When I look at the next one, sorry, I got jiggle hands today. When I go from 1 to 2, you can see that I went up only 3 boxes. 1, 2, 3. 3 boxes from this part right here. 1, 2, 3. When I went from, I really do have jiggle hands. When I went from 2 to 3, I went up only 2 boxes. And then when I went from 3 to 4, I went up only 1 box. Okay. So when I look at all of these lines, the one that's going up the most is basically the first one. This one right here, right? Because it went up 3 boxes. So my answer is 0 to 1. Okay, let me get my phone and take a picture. So let's clear this. Let's go to the next problem. So let's look at this one. So take a guess of which one had their greatest average speed. So same thing, rate of change and speed are the same thing. So which one of these went up the steepest? Now for me, I'm not quite sure. It could either be this one or it could be this interval. But it's definitely not any of the other intervals. So if they're close, what you can do is, again, you can compute the rate of change by using the formula y2 minus y1 over x2 minus x1. So if we look at this first blue one, okay, so rate of change and average speed is the same thing. This one is going to be 40, I'm sorry, 110 minus 40 divided by 2 minus 1. So that's going to be 70. Now, if we look at the red one, that one looks like 350 minus 230. And then we have 8 minus 6. So that is 110, 120 divided by 2 equals 60. Okay. So clearly, this is bigger. So my answer would be 1 to 2. But the nice thing about it is that we were able to not have to do calculations for all of these, just the ones that look like they were the ones going up the steepest. Let me give everyone a second to copy. Okay, I'm going to clear all my drawings. All right. So let's try doing this one. Okay. So go ahead and find the student's average rate of change. Okay, so let me just give you a little hint. Right, so they said from average, from age 20 to age 80. Okay. Oops. Huh, doesn't want to stay. So what we're looking for is age 20 to age 80. And because they're mentioning 20 to 80, we know that this is my X column here. And this is my Y column here. So go ahead and compute it. Compute the average rate of change is Y2 minus Y1 all over X2 minus X1. Okay, so we have 4.7 minus 2.3. Excuse me. All over 60. And this is equal to, oops, I'm sorry, I should do 60. I should do 80 minus 20. So you get 2.4 divided by 60 is equal to 0.04. Okay, let me give people a second to copy. Maybe we'll try one more question. And then if you have any questions for next week, let me know. I think that's our last week. So just email me any questions that you have. I'm more than glad to go over what you're confused with. Okay, so let's clear this. Then let's do one more question. So let's find a good one. Let's try number 100. Oh, that one's hard to, that one's time consuming. Let's do this one. Okay. Okay, now in terms of which one looks like they are increasing the most, it's definitely not this one. And it's definitely not this one, right? They're the flattest. I think we're looking at either 0 to 1 hour or 1 to 1.5. And since we're running out of time, let me knock that out. So if we look at the 0 to 1 hour, it is 700 minus, oh, sorry. Yeah, 700 minus, and over here, it looks like we're starting at 200 divided by 1 minus 0, and that's going to be equal to 500. And then if I look at the that's not good. Good, all right. And then if I look at the 1 to 1.5 hour, I'm looking at 900 minus 700 divided by 1.5 minus 1, which is equal to 200 divided by equal to 400. Okay. So the one that's bigger is this one right here. Right? 500 is bigger than 400. So it'll be right this one right here. Okay, thank you everyone. Thanks for working so hard. You got one more week. So good luck on the practice teas. Okay, and if you have questions, just email them to me and we'll work on them on the last workshop. Okay, thanks everyone.